Okay, on the SOL, you're going to need to be able to determine empirical and molecular formulas. So that's what I'm going over in this set of videos. First thing we're going to do is, this is Chapter 11, Determining Empirical Formulas. From this sheet, we're going to work on number 5. And then on the back side, we are going to work on number 5 actually as well. So, this video is all about determining empirical formulas, and I've copied out the problem right here, and you can see that we're given in number 5 on this worksheet that we have 32.4% sodium, sulfur, and oxygen. The first step that you're going to take whenever you're doing empirical formula, molecular formula, percent by mass, you're going to assume that you have 100 grams of whatever substance you're working with. Okay, so if I have 100 grams of this substance, then I can assume that 32.4% of 100 is 32.4 grams. So 32.4 grams of sodium, 22.5 grams of sulfur, and 45.1 grams of oxygen. I'm in grams here, but I need to move to moles because I'm going to write a formula. And if I write a formula that says like CO2 here, what I'm saying is I have 1 mole of carbon and 2 moles of oxygen that are bonded together. So in terms of this formula, I don't have moles, so I need to compute them, and basically I'm going to use the format that we've been working on with STOIC. And that is, I'm going to do dimensional analysis on the first one, and then the next two we'll just go ahead and do a shorter way. But what I'm saying here is that I've got 32.4 grams of sodium, and I want to know how many moles that is. So I'm going to put moles of sodium up here. Now, I know how to turn sodium, how many grams are in a mole of sodium, because I've been using it all year now. When I look at the periodic table, I see sodium, it says 23 grams, and so roughly. So I'm going to write 23 grams of sodium is equal to 1 mole. I can do that. I can put them on top and bottom because they're equal to each other. Then I go over here and I see that I have grams of Na on top, grams of Na on bottom. That means I can cross them out. And now I just have the numbers. I'm going to take 32.4, which I got from the problem, and I'm going to divide it by 23, which I got from the periodic table. So it's the problem over the periodic table. And the number I get when I do that is 1.41. Crazy number, but we're going to work with it. Oh, and 1.41, notice I got rid of grams, so I'm looking at moles. So I have 1.41 moles of Na. Okay. Now we're going to just take a shortcut for the rest of them. I'm going to save 1.41 moles of Na. I'm going to say we're going to take the problem, the amount given in the problem, divide by the periodic table. So, amount given the problem, I have 22.5. Amount on the periodic table, 32. That's the atomic mass. And when I divide that out, I get 0.70. Notice I put moles of sulfur. And then oxygen, the amount given in the problem, divided by the amount on the periodic table, gives me 2.8 moles again. So I have the moles, so I can do something like CO2. I can put the numbers down here. So I'm going to. I'm going to see, let's see, I'm going to do Na. I have 1.41 moles of that. Sulfur, I have 0.70. And oxygen, I have 2.8. And I'm done, but not really, because we never mark moles in decimals. You always make them whole numbers. So the easiest way to do this, George, is to divide by the lowest common denominator. There you go. So I'm going to divide by 0.70, all of them. If I do it to all of them, it works. Okay? And when I do that, I'm going to see I have Na and more or less 2. It's a tiny, actually this one isn't very off at all. If I put the 1 in, yeah, it's a little off. But it's Na2 and then S, and that equals 1, so I'm going to leave it blank. And then O, and divide those out, I get 4. Na2SO4. That's my my empirical formula. And I also noticed that SO4 is one of my polyatomic ions. It's sulfate. So I'm just going to put parentheses around it because it's sodium sulfate.